Hello, everyone. Thanks for coming to our 20th ClueCon. It doesn't feel like it's been 20. You know, it's been, I think we started doing this, just out of the blue. We thought, how hard can it be? And the next thing you know, it's been 20 years, right? So we started ClueCon with just let's all just go hang out. We don't know what we're doing, maybe, and I think not knowing what we're doing sort of was the secret. Sometimes when you just do things, that's how you push a way forward on things. If you do things the way everyone always does them, you'll tend to just keep making new kind of derivative versions of the same thing. So I think kind of the catalyst for some of the things we might have done along the way started with that naivete that we sort of just went with, and here we are. So it's been kind of an interesting journey through this entire world. When we started doing these things, we're all actually very new to them because the things themselves were new. Some of the things on the internet were sort of taking off, but not really all the way there yet. We started out with, getting into telecom because we thought it would be cool, and we weren't even dreaming about, at first, using the telecom inside the internet. We were thinking alongside the internet. So we were thinking, we'll get on a normal phone line, however that works. We're going to use, say, landlines or circuit or whatever, but we're going to adjacent have a really cool web page. And agents are going to imagine the world if the agents could be at their computer from anywhere and they could talk on the phone and do their job. So I mean that was kind of the beginning, because it was well, the internet is so cool. We were just thinking about it as a conduit for documents and applications back then, right? So there was a little bit of a experimentation with let's actually communicate real-time media over the internet. But one of the reasons that it sort of slowed down was, in order to do it, you needed internet. So it's pretty cool to do between data centers, because they had really tight internet. We'd have one or two different data centers in the world, and you could make imaginary trunks between them instead of paying lots of money to go through physical circuits to interconnect your data centers. But your house, you're lucky if you had a modem there. And some of us were first adopters, waiting in line for ISDN lines and then right to cable modems, but other people were kind of on dial-up still. So the really cool kind of voice conduits were limited by there was no delivery mechanism to ordinary people that don't want to spend maximum dollars on having the fastest internet as soon as it was possible. So there's a lot of work we put into just focusing on that, let's make cool applications. But we play around with the voice stuff, what if the voice could go to the internet too? And we experiment with it. And that's kind of around the time when we started thinking about things there's a few open source projects that have already started implementing some protocols that allow voice to travel over the internet. There's a couple applications that you could download to your own computer and run it. If you're lucky, you would learn the art of using really compressing codecs that there were out there at the time to try get that. It sounds kind of funny because you're calling in on a modem, but you're trying to then have a voice call through the internet that's already running through your telephone lines, but you do it anyway, and let's see if we can compress this down and run this call through it. And then you start getting all these ideas, what if everyone could always talk this way through the internet? If the internet was only bigger, then we would be able to, create these kind of imaginary phone lines to all the devices that can handle the internet. So that was a bet that we started to make, because that's probably going to happen. That's where we were, right? It seems like it's evolving quickly. So there was a bet there, and the other one was on physical equipment becoming more ubiquitous. So at the time, you could get a cool server if you went and you order one and build it and run it in a data center somewhere. You can put a couple CPUs in it, run cool server, and no one wanted to run other people's cloud back then because they're all like, I have my own rack, and it was cool to have a rack back then, so we're going to put it somewhere. I'm going to go there and look at my computers in the closet and turn the air conditioner on and all that stuff. It was actually kind of empowering. So it was like, look, we have servers in the internet, and we're going to run software on it, but they're very hard to come by. So like when I started thinking about these things, you had 2 cores if you're lucky. Like an 8-core server was like 25 grand. So you're like, most people aren't going to just buy one to play with like a toy. When I first started, the first kind of few cuts of FreeSwitch when I started working on it were on little tiny 2-core servers. And so another big bet on that was concurrency is going to take off, and we're going to have to figure out how to run software that would be inside, scaling horizontally compute and not vertically. Because at the time, everyone was racing to make the processor faster and faster, but it seemed like we were going to run into some limits that would slow that down. And we already knew from 10 years before that the other way to do it is to have parallel processors. So we put a lot of effort into thinking about that. These are kind of like early predictions of ours, because they haven't come true quite yet, but we were thinking we want to use up as much of the computer as we can, because you never know how many processors. Unix can run parallel processors, they just happen not to because we've been running Linux on our desktop computers to play around with it. When you get back into the server world, multi-processor core Linux kernels started becoming normal. It used to be you'd have to get it separately. I want to run the multi-core kernel. You'd have a whole different one, the monolithic 1-core kernel and the monolithic multi-core kernel. So, started playing with that. Let's see if we can use different ideas in the technical implementations to take advantage of all that, because in one computer, a lot of applications kind of just run and take over one of the cores, and they just expect that as you run various applications that the scheduler is just going to bounce them around to the cores. But what we wanted to do is take the computer over completely. Like, you belong to me now. We run it like at a high escalated level, take on the scheduler and turn on a more performant one that you can't get to unless you're running privileged. We thought of all these different things of making sure that we were spreading out as many threads as we could so that we could light up all the cores. So if we're going to write a lot of channels and cores and to the cores, we would see them equally burning. And so when the server is about to die, you would have almost equal percentage. If it was 32 cores, they'd all be like at 80 or 90% instead of just one of them pegging out. So that was a lot of things that we did. But while we were writing it, we were thinking about, how are we going to do this? We've got computers and we have telephones, and like, what do they have in common? And how are we going to put things together? So we're trying to look at all these different things we have, and we're trying to think, okay, how can we find a way forward where we take this paradigm, what we know about telecom already, which is, so you have a lot of analog phones, nobody knows anything. The people who invented phones really think we're all really stupid, so they made them easy. Almost anyone can understand how to work a phone. They would not put any features in phones. You listen, you hear it making a buzzing sound, and someone wants to call you, and you can like pick it up, and all you have to know is to type 5 digits or 10 digits or whatever it is, and then someone else shows up on the other side. And that was pretty much done to make sure it would become ubiquitous, and because the technology was pretty difficult to scale to large amounts of people. So you have like phone lines going to every house in an entire city and country. Those networks are interconnected, and they just wanted to make them easy. So we're looking at this, and we're saying, how do we move forward from what we've already seen happening? There had already been some open source projects starting to implement, what we would call FXO and FSS implementations, which are basically to trick one of these Ma-Bell phones into thinking it was plugged into the actual telecom network. Those devices were cool. Everyone had them. We were playing around with them in the lab. It's like you stick this card in the back of your computer and you plug the phone into it, and it thinks that it's like connected to the phone company. Or you plug your phone line into it, and it thinks that it's terminating into a phone, but it's really going into a computer. And that's where you started thinking about these things. And there's a lot of community around that. Several different people that put a lot of work into trying to like bridge that physical to digital world. And around the time when we started solving these problems, those were part of the building blocks that started to appear. And what we were trying to do is figure out how can we move forward and like kind of keep an upward momentum on some modern things too, so we're not always thinking everyone's stupid and all you know how to do is to dial numbers, right? What else could you do? Even in the earliest days, you know, we started working on thinking about how could we interact with people besides dialing numbers. It's obvious that we know every phone has dialing numbers, and we know every phone has a media stream. So, you know, spoiler alert ahead, when we start talking about AI for the rest of the week, like we already were wondering in 2006, like imagine if you just talk what you want into the phone instead of having to type numbers. Like how many ways can you express what you want by typing numbers? The least common denominator is press 1 for sales and those kinds of things. That persisted for a really long time. And we had TTS and speech rec back then, except it was like so new that it was done in academic places, and we had access to it. A lot of the colleges, you know, like Carnegie Mellon was investing their time into building both directions, and they actually kind of made a lot of cool, really open source stuff. But like speech detection back then was you'd have to be sure ahead of time what words you wanted to detect. You couldn't just detect anything. You had to think of like 5 keywords that were really important, and if you got it right using a physical lexicon, it would be able to detect that one word. So it would kind of pretend like you're telling the computer what you want over the phone, but it was just listening for one word. If you're lucky, it would take that one word and then make it mean something. So that's why to this day we're all barking at phone systems going, sales, human, you know, because that's the only thing it could do forever. It was this new one word. And the speech generation sounded pretty much like a speak and spell. You know, it could do that. Even like Apple computers before PCs took off kind of had this really kind of war game speak and spell kind of voice. But that was cool enough to play with for hours, you know, make it say funny jokes and whatever. So like we're taking these things and we're like, we're going to put those in the phone. And we're going to make like cool voice menus, because one day you'll be able to just like talk on the phone to an imaginary robot that's going to solve all your problems. You know, but we start out with this, you know, early things. So we built interfaces around it because we said, this is cool, there's no way this isn't going to get better. So we're going to define an interface specifically for some of these paradigms, because as they improve, we'll just plug in new versions to the same infrastructure. So we started working on, let's build the core of FreeSwitch, and we'll make it very modular, and we'll anticipate speech rec, you know, ASR we call it, and TTS, text-to-speech, and routing, and a whole bunch of other cool things that you're going to do all the time that we know are going to get better. So we planned ahead. We'll just make that modular. So we'll get the core right, because maintaining 100% of a computer is hard, but the other stuff's going to keep growing. So we're covered on the compute side because our strategy continued to become easier underneath for free, because we're using Linux a lot. You know, we run on Windows, Linux, Mac, anything that'll compile. We don't always make sure it compiles anymore, because we got literally like overwhelmed to the point of tears. Once there was like 1 million different platforms. There's like 30 variants of Linux alone, and BSD and Mac and everything. Some people kind of do it for fun and adopt one of those like different ways of doing things, but for a while there we were keeping it up to date. So like you just type make from checking our code out on all those platforms and it would magically work. Can't be sure that's true anymore, but it does still end up working as long as you get over the, you know, every year the maintainers of all varieties of Unix think it's fun to break everything by making it different, right? Starting today, we don't believe in this paradigm anymore. Now I won't compile. And so like, there's always like, every time there's a new kind of release of a compiler and the tool chain and a variety of Linux, it's 6 months of just changing everything to match all the kind of like evolution, I guess, of maybe in their eyes trying to make it make more sense and more secure, but to a maintainer, it's like, are you kidding me? This has been working for 10 years. I'm gonna have to go edit every one of these files and make it differently. So all that stuff, like the dark side of that annoys us, but the bright side is Linux Scheduler was a toy when we first started FreeSwitch, and now it's like amazing. But when we started FreeSwitch, threads were like a weird thing you loaded. It wasn't part of the operating system. It was like a library you have to have. And the processes were separate and implemented in a different part of the system. Now they're identical. Like no one even knows that anymore. It looks the exact same on the outside, but like processes and threads and all that stuff are just all part of one magical scheduler system. So like the more we started doing these things, designing it from these aspects, then we started getting bonus features almost. Just the better things got, and everything started going to virtualization. So even early on, in the beginning of 2000s, that's when we started getting the first kind of virtualization stuff. The Virtuoso used to be a separate thing, got kind of built right in the Linux kernel. Linux kernel got jealous. They made their own called like Linux containers. Next thing you know, you've got a whole bunch of alternatives. And then you have Docker, which isn't virtualization, but it's kind of the change root jail we all wanted back then. So these things started to evolve around us, and we just pick it up, benefits from it, because the modular design that we thought through found its way to running better on virtualized things too. And it wasn't easy at first, because when you run virtualization, the early ones especially, you're like kind of sharing imaginary computers with whoever else's imaginary computer was in the same machine as you. And it would kind of trick your software into thinking it was alone on the computer, but really there's only so many resources and so many kernel context switches that you can pull off on physical equipment. So it would just think, who cares? It's just websites, right? Like no one really pays attention to how long it takes their website to load, and it's just like you send email, like it's all in the background, but we're doing like voice over IP, right? So you run 20 millisecond audio stream 2 ways, that's 50 packets a second that you have to get on time, or everything starts to sound crappy. And if the computer just randomly like goes to sleep and leaves you frozen in time while it's going to deal with somebody else's stuff, then you have a hard time and you get a lot of problems. Or it thinks you're trying to be efficient, so you're so efficient that the computer thinks that the computer's idle, so it shuts sort of itself down because it thinks it'll wait until it gets some magic event that will tell it that it needs to do work. It's like, actually, we're streaming media here, 10,000 streams of media, and like you just put us to sleep and took all our calls away, and like all this fun stuff. Like it didn't take that much work to get over it, but it was a few years of that. But it was worth it, because then it allowed us to exist in a world that eventually became your DigitalOceans and AWSs of the world. So we started to pick up steam somewhere in, say, about 2008, because we realized that we have to have a real release. Some of our friends in the world of software design, like SpanDSP and the author of that are one of our really good friends, and we've known him forever. Like he's still on version 0 point something. It's kind of a funny gag. We almost thought about doing that too, but we had to get to a 1.0, and we sort of put that out in 2008, and that kind of really told people that we weren't screwing around and we were serious about it or whatever. So, but by the time we did that, we started seeing, what are you going to build, right? So the early adopters were thinking about trunking at highest pace trunking. So like, because the internet still wasn't going to everyone, at a high enough speed to have phone calls go through the internet. Some of us had it, some of us didn't. But say you have like these data centers and you can trunk between them, a lot of people are starting to do that, because it was a really good way to bypass the horrible route you'd have to go by running through like ISDN lines and stuff to get from point A to B, because you could just kind of make a magic tunnel between two places on the internet. The carriers used to say there's no way that's going to work. Like, you need to go through our special expensive wires in order to get to the other place. Until they finally gave up and started offering it and selling it to people too. But in the meantime, because we had these things available, you had these sort of service providers that emerged. They were becoming like almost like digital CLECs, who were like giving you these like high density trunks from one place to another, allowing basic phone service to travel. And this is a time when like everyone's using ISUP and whatnot at the highest level, subtrunking or whatever form of that you're trying to use is almost more featureful than that, but that's enough to light an entire country up, right? So like, you're starting to put two and two together that we should really start like having more phone networks to go through these pipes, because we don't have to go and pay everyone that if it's a hopscotch jump all the way from A to B, you have to pay everyone in the middle. You make this magical warp zone between the two, you just send all the calls like right past all of that. So then you can like sell direct to consumer almost. Little tiny companies could get internet service and pump all their calls in over that internet pipe. Although it was very Wild West back then, and setting all those things up was super hard. But the ones that figured it out, like all the DevOps kind of strong people, it was heaven, really fun. Like, let's connect FreeSwitch to an AS5300 from Cisco and like make it reboot, because we sent so many calls to it and they're bragging how cool they are, but like they can't even handle the traffic over one T1 line worth of SIP. We had many fun days going through that, like realizing the kinds of scale that you can put when you use the internet. I mean, it was so hard to even reconcile that at one point our team wasted at least 2 days thinking we found a bug because we hit a plateau of how many calls we could have, until it dawned on us, how can we have any more calls? We used up the entire 100 megabit internet pipe that this thing is connected to. It was literally saturated with calls, so like, I can't have any more calls because I managed to use all of my internet. No one ever got close to being able to do that before, so it didn't dawn on us right away. But then we realized like we're going to need a bigger pipe if we wanted to like really find out how much you can do. In some cases, we'd have to get internal gigabit lines and run calls inside of it so we can just see where it really could go to. And that's kind of how we figured out that we could take a server. However, by this time, finally, like when I started, there was only like I said, 2 cores. 8-core boxes were cost prohibitive. But you're starting to get those 8 and 16 core boxes kind of like just handed to you off the shelf now. That's the default they came in. It was harder to actually find single core ones. So we're getting into where we're seeing scalability being able to happen. And we found out how to take a computer and literally just control every inch of it. So when people would start to deploy FreeSwitch in the server, they wouldn't just run it as one more program on their computer. It would be just for FreeSwitch. This is almost like FreeSwitch was the operating system. It was one level above it, but it would completely command and take over every resource in the entire computer. There really wasn't a lot of room. Sometimes you could have a little reporting thing in the background or whatever, but nobody wanted to share. They wanted to give FreeSwitch all the power of the computer so that it would scale as far as possible. And when we started seeing people reducing their the server footprint by like a 10-to-1 factor. Okay, so, but what we found then was you could take 10 servers that were load balanced in a very generic way, still kind of treating people like phone calls are super basic and all we're going to do is send you a dial tone, where you can scale that because when a call comes, you just like round robin them to a cluster of servers. Every call is independent, so that works okay. I don't have to worry about like, how am I gonna scale across like more complex scenarios. And so we had this kind of ideas starting to form where we're like, we have we've taken over the computer to the most we can. And then we started experimenting, like what about when we went like 100 computers? Like, how do you run FreeSwitch on 100 different computers at the same time? And have it seamless, so like not just calls, but when you start wanting to control the calls and interact with them, because this era that started to happen was dawning the age of the first CPaaS, where they were thinking like, this is too hard, let's make it easier for people, we'll give it to them in a REST API or whatnot. But you're still like stuck in these paradigms, though you can only have kind of one call at a time and some round robin stuff, and like how do you deal with fault tolerance and horizontal scalability, and really getting some of the more creative functionality to exist. So being able to do that is super hard. And I know this not only from accomplishing it, looking forward to, I would say, soon, but before that, I helped other people try and accomplish it over the years. In very large companies who had a lot of resources, and all the king's horses and all the king's men would try and launch like 1 million free switches. They're all like unable to reconcile what each other is doing and asking us for help on figuring out ways to scale them together, because they wanted to make some cooler user experience thing that requires a whole bunch of complex logic. But they can't really scale it to more than one computer because they have to sort of steer all the calls in the same place. And this is a problem that never goes away completely. But in the early days, it was rampant because there was literally, if you're just selling like dial tone to people, then you can scale because you're just picking, there's 20 servers, you pick one in an endless loop, round robin, like we did with web servers. And we learned a lot about how we're going to scale technology from how we did it with web servers, because web servers are very transactional. So we're just requesting a website, give the answer, request a website. As long as they all kind of had the same content on them, you could just keep spraying it through a whole, like, take a proxy and put 1 million behind it. That kind of idea kind of made APIs come out. You know, like, what we think now as REST APIs and stuff is like where all the old web server technology went in its retirement. Used to be the way you actually delivered the real websites, but now it's more like a way to scale, transactional REST APIs and that kind of thing. So we're thinking about like how do we do things that are higher level. How do we control the calls while they're running? I want to talk to my running call and tell it I want it to do something different. I want to move it around. I don't know where it is. It could be floating in one of those 100 servers. How am I going to find it? And I'm going to tell it I want it to suddenly start recording, or I want it to switch to doing something else. I want to make fundamental changes about it. I want to ask it questions. That's harder to do when you don't even know where the call is. And trying to build all those things ended in tears many times for some groups. They would build things, and then whoever was working for them would sort of peace out. I had enough of this. Have fun with your system, and then come to us, and we'd try and help them. We mainly learned a lot from those experiences. That like there's a really big problem, and that we were going to have to try and solve that too, because we are sadistic, and our entire point of existence is like solving impossible problems, right? So. Now, what is the next one we're going to solve is cloud scale. Buzzword. I love buzzwords because mostly when we talk about them, we're not kidding. But when we heard about cloud scale and cloud native and all these fun words, you know, we're a telecom company that is doing voice over IP for a living. What's the cloud? Because every server I've ever used has been connected to the internet, and all the calls I'm using are over the internet. So like, haven't we been on the cloud this whole time? It's a cute name for it, you know, but like, what does that mean? Then we start to learn, okay, I guess it means the enterprise is trying to make you really like their solutions, so they make it sound cool, but really they just mean like scalable things on the internet that don't make you really sad. So we're thinking about these things, like how are we supposed to do this, because we have this kind of limitations. People are kind of used to what they think the CPaaS is, but it's like mainly a conduit for text messages, because that transactional model works perfectly. You can scale a text message business. pretty easily. You just put a bunch of servers on there and use that same kind of Web 1.0 kind of load balancer trick to set it to a whole bunch of, maybe you have to have a central queue. It's a little harder, but like, what about phone calls? What about live communication over multiple mediums? What if those phone calls are coming in from a physical network and being translated to digital, but you also have some people that are on these fancy new phones that actually plug into the internet? What about these phones that run on your computer? You have these cool like soft phones, and now the web browser decided it wants to get in on the act, and you can use the web browser as a communication channel up into different cloud services. Everyone that was using stuff in WebRTC was kind of like, hey, cool, we're just going to forget about the telephony. WebRTC is cool. All we have to do is everything's in a browser, and there's no real world, and we'll all live happily ever after in our little tiny cloud bubble. And then other people would come and say, oh, I don't like that. I want to actually have my telephony calls mix in with the cloud bubble. And most people would design things in a way that was one or the other. And for us, it was sort of how do we find a way to do this where we're retaining our original goals and our reason for existence, but also getting involved in giving ourselves time to go to sleep at night, because at the point where you're trying to engineer everyone their own solution in this kind of problem ends up with you like working 24 hours a day, right? Like you can only scale so much with people and software, and like every one of them wants the same thing, but they want to do it by themselves in their own different ways. But it ends up being the only way to do this would be to spend like a certain number of resources for a certain number of time with a certain number of very talented people. And if you multiply that times everyone that wants it, you're going to be wasting the rest of this whole century. So when we're looking at this puzzle to solve, the first question was, like, what do we want to get from FreeSwitch? I put this kind of OG image in here. This is one of our old books that came out like 10, 15 years ago. I gave a speech with this picture. I was trying to describe in my head what FreeSwitch looks like, because it's got like, there's certain parts of FreeSwitch I don't want you touching. Like, don't even give me a pull request. This is my core. There's a 3-headed dog guarding it. Like, I'm going to have 8 people do a review on this pull request, and we don't change things very much because we want to make sure that we don't let down everyone using it. But then we give more leeway in what we call modules, where we give you kind of it's like satellites revolving around the core, and that one was a little fair. We wanted you to work there as a contributor because we were defining the interface for you. And that way, we keep protecting you from yourselves as a developer, including literally ourselves. We would write modules and things because even we don't want to touch our own core unless it's really important, right? Like if we're solving a problem and we need to do a patch into the core of FreeSwitch, me even, who wrote a lot of it, and my team, very scrutinized. Do we really need to write even one more line of code into the core, and why? And there's a giant committee about it. So we try and protect that. And we want to be able to remain extensible, because FreeSwitch has always been about thinking forward and being able to plug in more technologies as they appear. We started out with a theme where we showed like a caveman like carving a wheel. Our very first website that's probably in the Wayback Machine still shows this guy, and we'd always say there's, like, don't reinvent the wheel. It was one of our early kind of mantras. So we want to, if there's something that does something really well, we want to integrate with it, not duplicate it. You know, some people are like, I can make my own version of that, and it'll be cooler, and that's kind of just hubris, and we never tried to think that way. We'd say, this thing does a really good job at that, so I want to use it. So I'm making a module that will connect that into my network. And we also have allowing those things to flow. So my design from day one is inspired by the way that Unix works. I'm kind of a weirdo because I had Unix computers before Windows and any other kind of, I didn't even have a computer in my house when I started learning it. I just went to a mainframe somewhere typing into a VT100 terminal. So I've been very influenced by it. And the kind of the Unix way of doing things are things flow inside of each other. There's an abstraction, an elegance you cannot duplicate, where if you build things as plugins inside of each other, and almost like Russian nesting dolls, that you can kind of solve so many problems that you didn't even anticipate. You can solve all the ones that you did anticipate too, but you get bonus ones. And you start saying like, wow, I didn't, like using these components together, I can do this problem that I wasn't even thinking about when I designed it that way. And a lot of it comes from people keep wanting to do stuff, and when they go to do it, they build something very complicated because it's the only way to get it to work. And we don't like that, especially because the more moving parts something has, the more likely it is to not work. We try to eat those problems and then spit back out something easy that saves you time. Like, we don't want people to build something on-prem to consume, even with a CPaaS that's got to consume a whole bunch of events and then reconstruct its idea of what's going on in the world with events over, you know, sockets that have latency and say out of order problems. And, you know, we have this really complicated sort of core engine that's got low-level primitives in C and whatnot that are really doing the traffic, acting as a traffic cop on events and making sure they all get understood in order and stuff. And as soon as you start just spilling them out, sometimes you need events and things, but using that to build some complex things never made sense. Like, even inside of the early days of FreeSwitch, people would try and write like an external program for it, and it would fail all the time, and then they'd open bugs. And we would get fed up and say like, okay, we just added one magical application, just run this, and like, we'll do all the work for you, and you'll get the same thing, and you won't even have to build it. So eating complexity has always been one of the things that we want to do, because the more you eat complexity, the more you move forward. So if you think like, if you have an Android phone, that's really just Linux, right, running on a little handheld computer. If they made you type like a shell prompt on your Android phone, no one would be using it, right? So like, as soon as we figure out all the things you want to do, we put UIs in front of things, we make like services that don't make you do all the work by yourself. So we move forward on that and every step forward. So how are we going to take those things and use them to take things to the next level in this crazy era we're in? So we wanted to take what parts of FreeSwitch can we use to do these kinds of cloud scale, but also we can actually use FreeSwitch to do this, but we concluded not one-to-one, right? Because FreeSwitch is this one-box monolith mentality, I'm going to take over the whole computer. And some of the concepts that support it don't need to be all in one box, right? But the way that they worked and how we designed it and the usability and the product-led sort of evolution of how you do these things was born from endless thousands and thousands of like tickets and people talking to us on chat and whatnot, like what parts are really important. And this list here is just some of the ones that came up to the top. You know, everyone loves the call route. We used to have people asking us to do everything. I'll say to this day, we're talking how OpenSix and Camellia is here. We have held our ground. We have had people since the first year like, why don't you be a SIP proxy too? And like, no, have you met our friends at these other projects? Like, we are part of a complete breakfast. We are not going to do everything, but we are going to solve the problem we have, which is routing calls to applications, being able to gather every little iota of information that happens during that call. We want to figure out like a way to let you define, you know, all of your users and allow them to register, and you know, make them talk to each other and talk to other resources that are out there. Conferencing started out. The only time Mike Jarris ever went on vacation was in 2006. I don't know if he still has since then, but that 1 week that he was gone, I didn't have anyone to yell at, so I got bored and I wrote this conferencing module in like 1 week, and that turned into this giant monolith that's, you know, it got, our conference module has 5 million features in it from then. The first feature was just you could all hear each other, you know, but from there it just kept snowballing. It's almost like its own little robot programming environment. And that's one of the examples of what I was saying, because by the time we made the conferencing module, we had so many other interfaces and stuff that some of those other features actually plugged in together with it. And of course, being able to speak every protocol that shows up, right? At some point, like, now you've got WebRTC, there's no signaling, but there's media, and then it's a variation of SIP, and there's all these different signaling protocols, and how, physical lines are still possible, but mostly we haven't heard anyone ask for this in a really long time. So step one was what parts of this thing still have to be exposed, and how can we make them so that it all works together, because how can we build on top of everything that we were already doing? And then we look at what are people trying to make with all these pieces. And the ones that come up the most are these three, the asses, as we like to call them. One of these things is a platform on which you use to program and create and build things, CPaaS, right? But the other two are actually applications as a service, but they somehow kind of infiltrate the ass space by saying that they're a service. But applications as a service don't belong in this category, if you ask me, but that's just marketing. But we think of it now as UCaaS, CCaaS, CPaaS, and now you're hearing people say that they're making UCaaS APIs, but they're not really just wanting to use their app, and they have a few little personalizations. We're thinking, like, if we're really going to make APIs to make UCaaS, wouldn't it be UCaaS ass? Because, like, I'm actually trying to take the UCaaS and make that into a service, but I don't have a way to do that because all I can do is buy it from the leading brand. And same with CCaaS. There's like some really big call centers in the world who have made really cool software, but when you go to use it, you're stuck basically just like if you're going to subscribe to any other kind of app like DocuSign or something. It's just what you see is what you get. You log in, you just get used to it. Maybe when you're in the communication world, you're fighting between Teams and Zoom or whatever, and you're kind of just stuck, like, I'm going to use the thing they give me. Very good business strategy. They're going to rack up as many users as possible and then sell alternate products to them. But are they letting you build anything? Do you want to build stuff? Well, if you think I'm going to build my own and complete UCaaS solution, I'm just going to go simply get a copy of FreeSwitch and maybe a couple other things, and I'm going to put them on a server, and then all of a sudden it's like you have a long white beard because you've been stuck doing it for the rest of your life. Because you won't realize some of the pain that you will hit when you're trying to do that, which I know from watching many FreeSwitch customer of ours over the years trying to achieve some of these things. Some of them get a certain distance, and some of them, ended up having to get to Series F in fundraising in order to finally hit what they're aiming for. So the next thing you know, 10 years is gone. Sounds like a Pink Floyd song. But anyway, putting all those pieces back together into something that kind of solves the problems and retains, like, we're not trying to get rid of FreeSwitch because it's our baby, right? So we got to have FreeSwitch in there, and we got to have FreeSwitch compatible with it, because there's like so many ways that, like, we could unite every FreeSwitch box on Earth into a giant phone network still, right? Like, everyone that's running it, intentional botnet. Imagine if all FreeSwitches could find each other through a common cloud. But we're taking these things. How are we going to start with some of these other paradigms where you're trying to build these specific things like UCaaS to CCaaS, but you don't want to start all the way from the Stone Ages? So this has been coming for a while. I think multiple times. I guess some of you said you came to every ClueCon, so you probably heard me talking about this when it was almost a whiteboard. Just 3 years ago or something, I was just showing it as like a list of words and like an idea. It keeps fleshing out. We've been working on it really hard. So like, but the main idea around it was like, the internet has always been my inspiration for everything I do. Unix and internet. And the internet kind of, they dumb things down too, but not as dumb as the phone was. Because you have this idea, everyone knows how to work a web browser because you type in an address and then you get to something. I want to go to this cool website. I want to log into my favorite online app like Gmail or something. Like, this paradigm seems to be well adopted, and it's a big step up from like, I think you're so dumb you don't deserve to do anything cool, right? So like, I put that in mind. And thinking about resources, I wanted to do something familiar because R in URL is resources, right? We all know what they are already. I want to go to a resource. I fetch it by going to it in my web browser. And I thought, okay, what does that mean when we're talking about it in telephony? And there's some really key building blocks that represent those resources. It's, for us, a script, which is just a list of instructions which allow for call routing, IVRs, anything cool like that, where you're kind of making a creative application and terminating a call to it. Or you have rooms, which is the evolution of that mod conference. And then you have the signaling protocols, right? So you got to be able to understand SIP and WebRTC and all those different things. Except WebRTC, kind of put it on us to make signaling for ourselves, which we did in 2013, which we started defining like a JSON RPC-based signaling protocol that would move things past just getting the call working, and also once you establish a connection to something, you could start communicating with it at another level besides just talking to it with DTMF digits. You could send like commands and messages and get statuses back from it over the same connection status that you've established. So then people like to provision things because they have their own magic too. So instead of using necessarily Rust exclusively for controlling calls and whatnot, we also created a provisioning system that would let you create those things on demand. Like, I want to create a room in advance and have it exist, and I want to create these users and have them have accounts, and I want to create call flows and all these kinds of things. You can provision them from your own infrastructure. So you're still doing all this, the fun part, and you're not doing the boring part. So we were talking about this kind of like giving you power tools, right? You still need to build stuff with a power tool. But like, instead of hammer and nail manually for 3 hours, you kind of have like the nail gun. So you're still building whatever you want, but you're not like killing your hand twisting that screwdriver because you got the electric one. And what we were calling this was Call Fabric. That has sort of been my pet name for it from the beginning, because I envision it like the entire world intertwined and using the internet to communicate. So this is sort of an overview of the things I was just mentioning. We had to call it Swiml because it's just funny. I mean, it's like, to reality is it's it's not a language, but it is, as far as what everyone else thinks a language is a dialect of understanding instructions based on seeing a giant JSON object, right? We wanted to do that because running an interpreter is so risky and dangerous, and we had learned that through FreeSwitch. Like, we would embed Lua, and we embed JavaScript, and we embedded Perl, and you could make really cool stuff, but like, you could accidentally exercise bugs in those things and make the whole FreeSwitch go down with it. You know, like, people would make a Lua script and they'd call like os.exit, and then FreeSwitch would leave because it was running embedded, or like just all these kind of weird things, running stuff like calling threads and then like calling back into the core of the script and like confusing it. And so it was like, how can we like avoid interpreters but still have all the same cool stuff that you did when you embedded Lua scripts and whatnot? So we made this Swiml, which gives you really cool ability to do that. So it's sort of an evolution from what you FreeSwitch users may recognize in like XML curl, FreeSwitch style plan. Everything in FreeSwitch was XML because JSON wasn't the thing quite yet when we started. It was sort of, a couple people thought it was cool, but it wasn't really like the standard or anything yet, and there weren't a lot of C software libraries to interface with JSON back then. XML was all over the place. It's very machine readable. We were just trying to get it so that, you know, you could human eyes could understand it, but also a machine would really understand it, and that was sort of the compromise we made. But now that we have sort of JSON in the world, we can define almost like the entire experience that you might have on the phone in a single JSON document. You can break it into sections. You can make your old school voice menus where you like listen to our options and nest into a separate menu and loop around and ask a bunch of questions. Once it got the answers it needed, it could use just enough logic to route the call. And this was like able to scale to like any amount of calls because just understanding the JSON is much less expensive than, say, like launching Lua interpreters or JavaScript ones and constantly running it through that. So you have all these ways to control calls and stuff. And what we had noticed was, you know, we came into the CPaaS industry too in SignalWire so that we would, you know, do something familiar. But like some of the ones that are out there were very limited because they weren't really designed around these concepts that we've been doing this whole time. So we wanted to expose what we do at scale. And what we do is very cool background asynchronous things and allow them to happen on top of each other. So it took a lot of kind of engineering to be able to simulate some of these asynchronous behaviors so that you could modify things while they're going. And we want to expose more of that, and this is a vehicle for that. So for instance, you can use it together with RPC APIs to do call origination, create IVRs and all these different things. You can spawn them on demand. You can actually feed a SWML JSON to an originate command. We don't call it that in the SignalWire version. It's just a REST control for call dial or something. But like, you can give it like the entire story of what you want it to do, like in the post. And that gives you a whole bunch of flexibility to wire that together. So say you have like your own network with a bunch of phones registered to like Asterisk and FreeSwitch and all that cool stuff. Like you can actually add it as a call route inside of your cloud network and terminate to different physical locations and all kinds of fun stuff like that. The AI agents that we will be talking about several times throughout the week, they're actually an extension of SWML. It's the perfect place to add a new feature. So when we wanted to make an AI agent API, that was like the ideal choice of a delivery mechanism, because anytime some cool stuff comes out, like anyone that's used to knowing FreeSwitch, when we would make another dial plan application, like so SWML kind of checks that box. And it has a companion called Relay, which is more like its parent, which is a dynamic version of that uses asynchronous live communication. Think of it sort of like ESL and FreeSwitch. Very similar JSON controls, only it runs over a WebSocket. So your Node.js application could be put in Docker and just create call control that runs live, or you could launch it from inside a browser application and control calls from there. And you get kind of a lot of the same functionality. They're actually merging together like every time we do another iteration. Like they're very dependent on each other. SWML can run almost all the relay things. And it gives a very good delivery mechanism, and it keeps you from like having problems with not designing things quite right, because we're a little lax on what we give out in FreeSwitch for scaling. When you want to use like a whole bunch of ESL applications, it's very like people get stuck on like they can't read the events fast enough, and then it makes the server bog down and the client kicks them off and all kinds of things. So we solved all those things by having like, instead of just having FreeSwitch be its own event system, it's got an entire cloud architecture around it that guarantees delivery and uses all modern tools to separate everything. And so another thing was the evolution of this conference module that started with Jairus going on vacation. Is now has so feature rich that it even supports two kinds of ways of doing video. Has like layout controls and moderator controls and different things with audio. There's like sub zones that we came up with so that you can like have sub conferences where people can listen to the call but be having their own side conversation that no one else can hear. All the kind of cool tricks that we wanted to scale out into what we call rooms. So those rooms are very useful. They speak. There's a whole bunch of cool like video broadcasting things coming. There's another one coming out now, Media Over Quick. We'll see if that takes off or not. But if that does, we'll just be able to have that. Currently, we can do SRT, which is kind of the cooler version of RTMP, going in either direction. So you can like broadcast a live feed into a room, or broadcast the whole room as a live feed over to another room, or to like an on-prem thing, interop with all those fun things like OBS and whatnot. So it's got cool video features, but it has the most important audio features, and it scales really high. So it kind of works, figures out the right place to live so that you can put hundreds of people in one call, which is like not always a thing, but like in our company, we have like all hands that averages 70, 80 people in it. We run on that all the time. We use it every day for our own kind of leisure. We eat our dog food. So the other thing that is kind of one of the most important things here is subscribers. When we built FreeSwitch originally, we kind of left the user management problem to the imagination of the user because we weren't sure what it was, almost like a question mark. We had a way to define a user directory, and we allow you to dynamically feed like one of those entries, and we tried to figure out how to cache it and stuff, and it would mostly relate to like registering on a SIP phone or something. So like if people are using us to register, which, you know, a lot of people kind of built little phone systems around us, but I recommend using proxies for that because many of them have like really nailed those features, because when you're only in signaling land, it's much easier. FreeSwitch is kind of being like a user agent rather than a proxy. It has a lot more work to do, so you get a lot more heavy. So it's like taking some of those jobs away from FreeSwitch is kind of a thing that we've always expected, but we wanted to, how can we do that where they all kind of seamlessly work together with all these modern things that are starting to happen? So we have, say, like WebRTC, and we have SIP, and we have PSTN calls, which are pretty much SIP2, but you know, we always like to confuse people in our industry. But we have all these different sources for traffic and phone calls. And how can we unify it? You know, so like subscribers is a way to provision an account that's agnostic to the protocol, that actually gives you the ability to register and communicate over your SignalWire space using any of those tools. So you can write your own applications, you can use one we already give you, we have a reference one. You can almost put one together, a kind of a proof of concept in one day where you just make a small soft phone or whatever. But you're calling in, as soon as you log in as a subscriber, then you start seeing like all this stuff that's going to take you 10 years, like user management. How do you wire that into your existing user management database and middleware? And I want to be able to kind of like create permissions and route those calls. And you're thinking about this cool app you're going to sell to all your customers, and then all these requirements start coming up, and that's what we're here to listen about, because we've been doing that from day one, like trying to take those problems and take them into a simpler form so that the part that you're spending your time on is that thing your customers want, not necessarily the physical feature, but like the experience on the outside. So we have also that, like I said, this is actually an extension of Swiml, but we made an AI agent voice API because, like I said, even back when text-to-speech sounded like speak and spell, we were anticipating this whole time, right? So we wanted to make cool robots to do stuff for you over the phone, and we decided, you know, we'll keep pushing on that, and we'll make automated scripts, and you can build kind of IVRs as writing code, which is already a really big accomplishment, because it used to be that IVRs were a physical server you had to buy from someone, and like you could only use them however they set it up for you. Like voicemail was $25,000 to get like a box that had voicemail in it, and you just put all your calls there. And we kind of had the early days, you could write that whole voicemail application as a script. But then we're seeing like those things annoy people, and most interactions with them end up in very big frustration on the outside, because you talk to the robot and then it asks you 30 questions, and then it doesn't really do anything with it, and then it transfers you to an agent, or you can tell it's going over G729 over to a different continent, and then they can't hear you because of that, because that codec takes the volume down, and you're like, they ask you what your account number is, and then you throw your phone down because you're like, didn't I just type it like 5 times even to get on the phone with you, and all these kind of older things. You can't make very good voice menus when you have to imagine every possibility and script them all out. So we've seen that it's a logical conclusion that you're going to want to use kind of AI-driven logic in order to define some of those experiences with more flexibility to kind of adapt to what people are requesting. Kind of the way that when you do as a web browser, the early days, the form, there'd be a web form. Like, we've made much cooler UI on web now, but like, it used to all be forms, right? You just like fill out the form. There's still some like that, and you hit submit, and then it decides to ask you new questions based on the last one. Leveraging the part of the AI that's hard, which is like orchestrating getting it to talk and speak and react as fast as possible, and like always listen to you first and let you kind of drive in adjusting, but making sure that it follows a certain set of criteria. We give that sort of as an interface that you can connect to, and then define whatever you want. And then you get all the fun part is taking like webhooks and stuff back to programs you write. The same way it's fun to write web programs, right? Like it's posting to you every time key moments happen, and it gives you an opportunity to inject and change what's happening. So you can write a really streamlined, easy program that handles very specific situations to walk itself through kind of workflows. So you're coding with the power tools, but you're still making the thing you're always dreamed of, but you're not necessarily like spending forever, with that manual screwdriver just trying to build the framework around it. You just start on day one. I can build this robot. It answers the phone. I can make it the old school way and have you press 1 for sales, or I can have it have a nice conversation with you. But either way, it's like immediately ready to have as many calls as you want thrown at it and scale to the moon. So that's kind of where we went with that. And of course, the other thing is, how do you access different resources? And those are one of the more painful things we ran into in the early days too, because we had like, okay, like SIP phones are cool. I'm going to run it on my computer, but what's the fields? I don't know. We all have these SIP phones where like they try and make it easy, but almost the only way to make it easy is to like host it all for you, because if it asks you, you have to fill out what port is it running on and which one of these 130 features you want to enable when I'm talking to this different client, and like it's so arcane, and most people are like, I don't want to do this. So maybe they use like a Yealink phone. But using it on your computer is a little harder, and like just like how do I access things? And I'm on a web browser right now, and I go to a website and I have to pick up a phone and call their phone number because I saw on the website. So the concept of addresses that we came up with, like where things are resources, they have to be accessed over addresses, right? So obviously the easiest one to comprehend is phone numbers, because we've all been doing that for this whole time. So good old phone numbers are still an address, right? You assign it. I know that if I call this series of digits, it's going to lead to this thing. It might drop me in a conference room. It might call me on my cell phone. It might call me on one of these SIP phones I have registered. But if I say, like, now I want to use something else, like SIP, then you're like, okay, SIP addresses. I have a SIP address I could give people, and if they call it, it's going to lead to all the same exact stuff. Except a lot of people are like, how do I call SIP addresses unless I have a SIP phone? So only people that want to call people over SIP phones kind of get a lot of mileage out of a SIP address. But then we also support WebRTC over HTTP addresses. So you could say, my application, you want to call me, here's a URL you can call, and that URL spawns like a mini phone, like in real time, and connects to that same thing. So you worry about it in two separate phases. I know I want to make a room that everyone can call in and have a meeting, and I want people to be able to call me on all my phones. You give it one web address for each thing, people go to it, you can give it a phone number and a web address and a SIP address, and they all just kind of lead to the same thing and save you all the trouble of trying to set things up 40 different ways. And in order to interface with those things, then we had to make SDKs, because we want to be able to join this network and both publicly and privately and interact and create call flows, right? And these call flows could be complex. Like I said, you might be on the phone. AI bot answers, transfers you to another extension that actually leads into a tunnel and rings like local phones on your network that are tied up to a asterisk or free switch box or something like that, where you might like have another menu after that one that asks you more questions, or you might have a call center that you implemented using all the Swiml and SDKs and whatnot, and you're jumping it into that process so they get in line and join queues and all that kind of stuff. So what we wanted to do for that was we're actually creating an interface where we're starting with sort of easier interfaces so that we can make sure we get all the features right. So we have support for React Native. If you hear about, there's a talk about Flutter coming, you should circle that one. You'll get a demonstration of how you can write an application using that too. Basically what we wanted to do was create a series of SDKs where you could also separate that from all your logic. So you're not building all these things. I just want to build a cool app that's got a very specific feature set. I know how to make apps. It could be a web app, it could be a mobile app, it could be running in both of those places at once. But if you make it with the SDK, then it has all the privileges of any other phone. And if you don't want to use that, you can just use classic SIP phones or whatnot and get all the exact same thing. It's like, I only want to have old desk phones and all my extensions are numbers still. Well, then you make all numeric addresses for everything and plug SIP phones in. But then you're like, I wish my website had a way to call into that main number. You can embed like a phone app inside of your website and call right into the same logic. So that's kind of the point of that. And so where we got to from that is like, what are we going to call this? Because we're making all those ass jokes. I think that like the unified communication bit carries a lot of weight because that's really kind of what we've always been trying to do. And I always make these jokes about unified communication. When I started writing FreeSwitch originally, meant that my email was like in the same place as my web browser. And it was like, they always redefine what unifying communication means. It's almost like a holy grail, and we used to snicker about it. So like, someone took that over again, and now it means like, essentially like a mobile app, like Facebook Messenger, that you could chat with your friends and call them on the phone too. Right? So we'll just stick with that. That's what everyone thinks it means now. And what we decided to call it was programmable unified communications. Because it's not a service. It's not an ask, because the ask was already taken, and UCAS ask sounds silly. So we decided to say that programmable unified communications is essentially this paradigm where you're able to mix and match like all your fun telephony things that you created into one kind of conglomeration. You can separate it into segregated spaces that you can run on the internet. When you scale to enterprise level, you can actually create physical points of presence with it, having dedicated resources in certain regions or specific customer. When you're not doing it at high scale, you can use a very widespread cloud, very agnostic, meant to run anywhere and to be interoperable with all the fun stuff that we've already made, right? There that you can actually say like, create what we call a FreeSwitch connector. Say all your PSTN routes go to your favorite provider. You can set that up and use them still. If you want to like, just have it as a backup. So the main menu is up in the cloud, and then it goes to your FreeSwitch infrastructure. And if something's wrong with it, the upstream will take over. You want to use it part of a defined strategy where you don't want to run every single phone line to every place in the office building all to the cloud. You can have one on-prem switch, but you can run it through that as a trunk. So all kinds of cool ideas that we've been inspired by from all the different things that people have been asking for. And so like the last thing I was going to do is just kind of a little taste. I was going to come up with I made a kind of like an example of something you could just build as an outside user, challenging myself to. I'm getting lots of bleeping for some reason. Yes, I understand. Okay, you done beeping? All right, I made this AI debate generator thing kind of during the hackathon yesterday. Essentially, just a crude web server thing, little TGI script. It'll send my commands over to the back end. And so It'll use SWML to spawn spontaneous AI agents to argue about anything you want. Then I just put a little flare on it, which is not necessary, but I thought it would be funny to have it have like visuals too. I'm going to drop these calls. When I press this, we can ask people if they want. We can try it with some other suggestions, but I put Darth Vader is better than Kylo Ren as the first topic, so I'm just going to hit submit on it, and we'll see if we get it. Might have to hit reload. My computer's mad from this weird power surging through it. Hello. I'm just going to unplug the video from it for a second because it's like, you guys might want to check that on AV. I think it's sending power surges through the computer and making it think people are typing.
Oh great, another Kylo Ren fan. I guess you like your villains with a side of whiny angst. Let's get real here. Darth Vader is the ultimate villain. He's got the iconic look, the deep voice, and a presence that makes you tremble. What does Kylo have? A temper tantrum and a lightsaber that looks like it was designed by a toddler. How can you even compare the two?
Wow, you really must have a thing for outdated villains. Darth Vader is like the VHS of villains. Sure, he has the iconic look, but Kylo Ren brings a whole new level of complexity. He's not just a mindless enforcer. He's torn between light and dark. That internal struggle makes him far more relatable than your overhyped breathing machine. Plus, let's talk about that lightsaber. It's not just a weapon. It's a statement. It shows he's not afraid to break the mold. What does Vader have? A boring old red blade. How original. Why do you think Kylo's character resonates with a new generation?
Oh please, relatable. Kylo Ren is just a sad little boy playing dress-up in his grandpa's armor. Darth Vader's complexity comes from his tragic fall from grace and redemption arc. Kylo's struggle is just him whining about not getting enough attention.
This is basically
And that
just,
lightsaber, it looks like a medieval torture
two AI
device.
agents
Vader's red blade is
in a
classic
conference
and
together.
intimidating. It represents power and fear.
They'll just
What
talk
does
to each
Kylo's
other forever.
lightsaber represent? A desperate
It also
cry for
helps
help?
me test,
If you
like,
think
the-
Kylo resonates with a new generation,
The
maybe you
response
should
time
check
to
the
each
box
other and
office
whatnot,
numbers.
but
How many people actually care about his character compared to Vader's legacy?
Wow, you really are reaching with that argument. Kylo Ren is not just some sad little boy. He's a character who embodies the struggle between legacy and identity. Vader's redemption arc is great, but it's also predictable. Kylo's journey is messy and unpredictable. That's what makes it interesting. And as for the lightsaber, it's a symbol of his inner turmoil. It's not just about power. It's about the conflict within him. Box office numbers. Really? You're going to use
Anyway,
that as a
they'll
measure
never
of
stop
character
arguing,
depth?
so I'll
How
just
about
build
we
on
talk
that.
about how Kylo's...
So that's just kind of like something just to demonstrate you could kind of build anything you want from the outside world with just a couple of REST APIs. So that concludes the talk part of my talk, but now we could, got any questions, we can discuss anything. You want me to launch another debate, let me know. Could do some controversial ones. Or ask me later, I'll run it for you in private. But
That's probably the thing to do,
You
Tony.
can get us
isn't
to
it?
argue about any two topics you want, no matter how ridiculous they are.
Great, okay. We do have time for one question as we change over to Diego, our next speaker. Of course, as you'd expect, Tony's here for the whole deal, so you can talk to him privately at any stage you want. But does anybody have one question they'd like to ask Tony before we move on?
Once in 20 years, someone, come on, you gotta have a question.
A 20-year anniversary question.
Yes. Whoever asked the question
Okay,
wins a prize.
I have a quick question, and I think it'll be a short answer as well. But as you talked, you mentioned that certain technologies weren't where they needed to be in order to fulfill your vision. I was going to ask, what was the most important technological change that enabled you to get where you wanted to go?
That'd be a close tie between the performance of computers, the speed of the internet being, we all now compare speed tests on our cell phone and get 20 plus megabits. Like, we used to wish we had 1 megabit a long time ago. Like, as soon as you have even like 500 kilobit, you can run audio calls through it, like with no problem, which is a great advancement. And we were really waiting for that to happen, because not only are we trunking calls from site to site, but now we can send them to you on the field. Like, you're at the beach and whatnot. Cell phones, we already think that's cool because cell phones let you do that a long time ago. But now we can do that with internet calls, which is even better, because now we can have private phone networks that run inside of those cell phones. And now that that's happening, cell phones care more about the data stream than they do the cellular connection, which will lead to things kind of the same way that Starlink took over for satellites, right? You don't get a DirecTV anymore. You just get Starlink and run YouTube TV inside of it, because you can also use it for your internet and all these other things. When your phone only cares about the internet, then you can also run things inside of it like phone calls. And once the internet is everywhere, that was probably the winner that really let us allow people to create products where everyone's working from anywhere they want to be and those kinds of things.
Great. Well, thank you very much, Tony. Round of applause for Tony Minessale.